Imagine spending $2 billion on a single aircraft designed to disappear. Not fast, not heavily armored, but invisible. For decades, the B-2 Spirit has been described as a ghost in the sky, a stealth bomber so advanced that radar simply cannot see it. A machine built to slip through the most heavily defended airspace on Earth without being detected. But here's the uncomfortable truth. The B-2 was never truly invisible, and today that matters more than ever, because while the aircraft hasn't changed much, the world around it has. Radar systems have evolved, detection methods have improved, and the very physics that stealth relies on is now being pushed to its limits. So the real question is not whether the B-2 is advanced. It is. The real question is this: what happens when a $2 billion stealth bomber meets modern detection technology? And does stealth still mean what we think it means? To understand that, we need to break the myth. The idea of stealth is often misunderstood. Most people imagine invisibility, like the aircraft simply vanishes, like radar waves pass through it without ever returning. But that's not how it works. Stealth is not invisibility, it is delay. The B-2 Spirit was designed to reduce something called radar cross-section. In simple terms, that means making the aircraft appear much smaller to radar than it actually is. Instead of looking like a massive bomber, it might look like a bird, or a small object, or sometimes nothing significant at all. This is achieved through shape and materials. The B-2's flying wing design is not just for efficiency, it is carefully engineered to deflect radar waves away from the source. Instead of bouncing back to the radar system, the signal is scattered. At the same time, the aircraft is covered in radar-absorbent materials. These coatings help absorb incoming radar energy instead of reflecting it. Together, these features make the B-2 extremely difficult to detect using traditional radar. But notice the wording: difficult, not impossible. Because no matter how advanced the design is, the aircraft still exists in the physical world, and that means it leaves traces. One of the biggest traces has nothing to do with radar at all. It's heat. The B-2 is powered by 4 jet engines, and like all jet engines, they generate massive amounts of thermal energy. Even with careful design to reduce infrared visibility, that heat cannot simply disappear. It radiates into the environment. And that is where a completely different type of detection comes in. Infrared search and track systems, often called IRST, do not rely on radar. They do not send out signals. They simply observe. They look for heat. And in a cold sky at high altitude, a warm object stands out. This creates a fundamental limitation. No matter how stealthy an aircraft is in terms of radar, it cannot fully hide its thermal signature. Physics does not allow it. Now, to be clear, this does not mean the B-2 is easy to detect. Far from it. Engineers have gone to great lengths to reduce its heat signature. The exhaust is carefully mixed with cooler air. The engines are buried within the wing structure. Everything is designed to minimize visibility. But minimize is not the same as eliminate. And as sensor technology improves, even small differences in temperature become easier to detect. But heat is only one part of the story. The second challenge comes from the evolution of radar itself. When the B-2 was designed, most radar systems operated in higher frequency bands. These systems were excellent at detecting conventional aircraft, but they struggled with stealth designs. That's because stealth shaping is optimized to defeat those specific frequencies. But modern radar systems are no longer limited in the same way. Low-frequency radar, for example, operates at wavelengths that interact differently with aircraft surfaces. These longer wavelengths are less affected by the shaping techniques used in stealth design. In simple terms, they can see things that traditional radar might miss. Now, low-frequency radar comes with its own limitations. It is less precise. It cannot provide the same level of targeting accuracy. But detection does not need to be perfect. It only needs to be good enough to indicate that something is there. And once that happens, other systems can take over. This leads to one of the most important developments in modern detection: multi-static radar systems. Instead of relying on a single radar source, these systems use multiple transmitters and receivers spread across different locations. They work together, they share data, and they build a more complete picture of the sky. This makes it much harder for stealth aircraft to hide, because even if the aircraft deflects radar from one direction, it may still reflect signals toward another receiver. It's like trying to hide in a room full of mirrors. You might avoid one angle, but not all of them. And as computing power increases, these systems become more effective. They can process massive amounts of data in real time. They can identify patterns. They can detect anomalies. They can find what was once invisible. But perhaps the most overlooked weakness of the B-2 is not in combat, it is in maintenance. The stealth capabilities of the aircraft depend heavily on its surface. The radar-absorbent materials are not permanent. They degrade over time. They require constant care. This means the aircraft must be stored in controlled environments. Temperature and humidity must be carefully managed. Even small imperfections can increase its radar signature, and maintaining that level of precision is extremely demanding. It takes thousands of hours of work. This creates a different kind of vulnerability. Not in the air, but on the ground. It limits operational flexibility, it increases cost, it adds complexity. And in a rapidly changing environment, complexity can become a disadvantage. So, where does that leave us? Is the B-2 obsolete? Not at all. It remains one of the most advanced and capable aircraft ever built. Its ability to penetrate defended airspace is still highly valuable. Its range, payload, and precision make it a key part of modern air power. But the world it was designed for has changed. Stealth is no longer a guarantee. It is an advantage, a temporary one, a conditional one. And that distinction matters, because it changes how these aircraft are used, it changes how missions are planned, and it changes what comes next. This is where the next generation comes in. Aircraft like the B-21 Raider are being designed with these challenges in mind. Not just stealth in the traditional sense, but adaptability, integration with other systems, networked warfare, electronic countermeasures. The future is not about being invisible. It is about being harder to track, harder to predict, harder to stop. So when you hear that a stealth bomber is invisible, remember this: it never was. It was engineered to delay detection, to confuse systems, to buy time. And for decades, that was enough. But technology does not stand still, and neither does physics. If you want to understand how modern air power actually works, not the hype, not the headlines, but the real engineering and physics behind it, make sure to subscribe, because in the next video, we're going even deeper. We're breaking down how modern radar systems are evolving and what that means for every stealth aircraft in the sky. And trust me, it changes everything.